Hi guys, welcome back to our channel. Today's class I am going to talk about difference between FPGA and ASIC. So this topic comes under VLSI design. So here I am making two columns. First column represent FPGA and second column represent ASIC. So first point is related to abbreviation of FPGA and ASIC. So what is the abbreviation of FPGA? So FPGA in the sense field programmable gate array, and ASIC in the sense application specific integrated circuit. So it's an expansion of ASIC. Then second point regarding design process. In FPGA, the design process is simple, and ASIC, the design process is long and complex. So long and complex design process. Then third point, speed of operation. So in FPGA, slower than ASIC. So FPGA is slower than ASIC, and ASIC at first compared to FPGA. And fourth point is related to whether the FPGA is reusable or flexible. So here FPGA is reusable and flexible, but ASIC not reusable and not flexible. Then fifth point is related to usage of language. So here in FPGA, design is specified generally using hardware descriptional languages. In FPGA, the designers using hardware description language such VHDL or Verilog. Then come to ASIC. So same as for FPGA, design is specified using HDL. So HDL represent hardware description language such as Verilog and VHDL, etc. Then sixth point related to operating frequency. So in FPGA, limited operating frequencies. So limited operating frequency compared to ASIC of similar process node. The routing and configurable logic block eat up timing margin in FPGAs. So it will take more time. Then come to ASIC. So ASIC fabricated process using the same process node can run at much higher frequency. So ASIC run much higher frequency than FPGA since its circuit is optimized for its specific function. So FPGA it operating in limited frequency, ASIC it operating in much higher frequency than FPGA. Then seventh point. So FPGA designer generally do not need to care for backend design. So FPGA designers generally do not need to care for backend design. Everything is handled by synthesis and routing tool, which make sure the design works as described in the RTL code. Unmade timing. So designers can focus into getting the RTL design done. So in FPGA, designers generally do not need to care for backend design. Then come to ASIC. So ASIC designers need to care for everything. So ASIC designer need to care for everything from RTL down to reset tree, clock tree, physical layout and routing, process node, manufacturing constraint and testing constraint. DFT in the sense design for testability. Generally, each of the mentioned area is handled by different specialist persons. Then come to eighth point. So eighth point related to high volume, so mass production. So FPGA not suited for high volume mass production. So FPGA not suited for high volume mass productions, but ASIC suited for very high volume mass productions. Then come to ninth point. So analog design are not possible with FPGA. So this ninth point related to analog design. So analog design are not possible with FPGA, although FPGA may contain specific analog hardware such as PLL, ADC, etc. They are not much flexible to create, for example, RF transceivers. Then come to ASIC. So ASIC can have complete analog circuitry. So ASIC can have complete analog circuitry, for example, Wi-Fi transceiver on the same die along with microprocessor core, This is the advantages which FPGA lack. Then come to 10th point. So 10th point related to cost. So unit cost is high in FPGA. In ASIC, unit cost is low. Then come to 11th point related to power consumption. So in FPGA, power consumption is high. ASIC, power consumption is low. Then 12th point. So faster time to market product. In ASIC, longer time to market product. So I hope you understand the difference between FPGA and ASIC. Thanks for watching my channel. Thank you.